my name is Peter Verhas, and in this short video, I will show you how you can use Geci Jamal module to generate some very simple code in your Java program. So in this video, I will create a unit test, which is testing a very simple class, which I create. Let's say I create it in the sample package, and it's going to be echo. And we will keep it as part of the Geci release, next release. And it's going to be something very simple. I will just have a string method named echo. And it does nothing else, but it simply returns the string that we were giving to it. And I will create a very simple test for it. Which just checks that it really returns what it was given to it. And actually, right now, the test and the tested class, because it's just a sample and the demo application, they are both in the test part of the project. But actually, this test project, which is a submodule of the main Geci project, doesn't even have main sources, only test Java sources. And if we look at the POM file, then we can see that there is a lot of dependency. And here we have a dependency on the current development version because this module is not released yet. So it has a dependency on the Geci test engine. And whenever Geci test engine is included in the dependencies with the test scope, then whenever the other unit tests run with JUnit 5, then this engine, which is a JUnit test engine, also runs, and it will start up the Jamal code generator, and it will do whatever we need. So all we will need for code generation is just run a test. So let's do some very simple tests. First, there is no code generation in it yet. And let's just do a very simple test. Test echo, and then just an assertion. Assert equals, we will need string, but it doesn't matter which one I select in the editor right now. And let's say that I compare whoops with I, and of course I need a system under test instance. It's named SUT, system under test. And then I just run this test. And we will see very soon, it's now building. And it also said that there are some external files which I can add to Git. I don't add them to Git. It compiles and it starts up from IntelliJ. And what you can see here in the bottom is that we started test echo. That's great. In the test echo class, and then it was running test echo method, and it was running nice. And it also started Geci Jamal code generation execution, and this was executed by the test engine for which we included the dependency, which I was showing you in the POM file that's here in this area. Now, let's say that we want to test this echo for null, empty string, some string that contains spaces in it. because these are the special cases. What we can do now is to make copy paste of this code, or let's say we just duplicate it, and then we can say echo 1, and then let's say delete the content of the string, and so on. But this is very cumbersome and copy paste, and we don't want to do that. Instead, we can ask Jamal to do it. And to do that, we can create a command which starts with /* exclamation mark Jamal. It will tell the preprocessor that here we come and here is some template which will be used as some Jamal template with some macros, and you will see how these macros look like. So what I will have here is that I will have something that I want to generate for several different strings. So let's just take it here and copy it here. And what is the parameter that's always changing? It's going to be this string. And right now I will just name it to be $string, and I'm using the $sign to separate visually the parameter from the Java code. But other than that, I could just name it anything. And what I will really need is a for loop which is supported by Jamal. And I write for, and then I will just write string in, and then I write whoops, I write empty string, and well, this will be the content of the for loop. And when we are dealing with Java Geci, because we are generating Java code, then the macro opening string is the opening brace and the %sign. Oops. So this one. And the closing is just the opposite with the %. And this way it doesn't get mixed up with the opening and closing brace, which is usually used many times in Jamal. But for the code generation, the Jamal processor is initiated with these macro start and macro ending strings. So this is what we have as a first version. And let's see what is happening right now. Just run the test again. And now I already see that there is some problem in it, but I will fix it soon. But making mistakes is also something that we can learn from. And it says that, oh, it changed the file. And actually, it was changing a lot of things until the end of the file, because I forgot to signal that I have an end. And // __end__ signals the end of the generated code. So let's say that I just have here any Java code. Doesn't really matter in our case. It will not be touched after the end by the code generator. And I can have several such code blocks which are generated. And I see that we have two problems. One is that it was missing. So, okay, I just delete it because it's duplicated. And there is some error in it. And And yes, that's because I am missing it here. I didn't see that problem. So I forgot to close this closing double quote. And Jamal doesn't care. For them, double quote means inside the macros nothing. That's just a character. And I was also missing the end to signal the end of the generated code. And let's run again now. And we will have two methods, two test echo methods. And which will also again a problem, but at least we see that it's generated, and then we will go on from there. Okay, now the thing is that whenever the code is generated, then because it's the source code and it's modified, therefore the test fails. The code generation signals a failure. It's not really a failure. It just means that your code as it was compiled is not correct. That's what unit tests generally say, that you compiled it, it was compiling, but it's not correct. And this is actually what code generation does, because it says that, as it was compiled, it was not correct because I had to modify it. You don't need to modify it. I have modified it for you. That's what the generator tells me. So if I run it again, then it's okay, it will be green. The only problem is that right now it generated some code which is not executable because I was not caring in my template that I need to have different names for the different methods. So then let's say that I have to somehow number these methods. And for that, we can use from the snippet module. So for that, we can use from the snippet module the counter macro. And we can just define a counter. And we can say that the ID of the counter should be, let's say, Z. Just anything. Really, it's a very short code. I don't need a special counter. And then I can say that, okay, I put it here. And this is a very special macro because whenever I invoke it, it always returns the number. And then it remembers that it should next time return the next number. So let's run it again and see what's happening. It's still not working, but be patient. Okay, now there is some problem. One problem is that the for macro starts with the @ sign and not a hash mark. Therefore, everything which is inside is not evaluated, and it's not evaluated even afterwards. But I can move it outside, and then it will be evaluated. So just let's just delete these things. Now it's really a mess, but don't matter. We just get back very easily. And then now I moved it out. And I still have this counter, just not inside. And anyway, it was an issue. If I define the counter inside the for loop, then for every iteration of the for loop, it starts again. So it was not only syntactically, but semantically, it was in a wrong place. Now it was changed again. And then what we can see is that the for was executed, but this part here was not evaluated after the for was generating the output. So you can see that this is what for generated as an output, and it has to be evaluated again. And for that, now let's in the meantime fix it. So we can run it again. And for that, we can do two different things. One is to use the eval macro, which is a built-in macro, but it's very easy for any built-in macro. If I write a exclamation mark in front of the macro invocation, then it will evaluate the output. If I, for some reason, need to evaluate it twice because the evaluation result still contains some macros that I want to evaluate, then I can write two for many exclamation marks there. But this way, it will first, the for loop will output with test echo z methods. And then when it gets evaluated, these z's will return 1, 2, 3, and so on, as many as we need. Let's run it again. Yes, and this is the first time that something was generated which looks nice. So if I run it again, it should generate exactly the same result. And then even the Jamal test engine should be green and nice because it just generates exactly the same result as it was. And also, let's see that I have here some multiple spaces, or I want it formatted a little bit differently. And if I run it again, I just want to demonstrate that the comparison is done on a Java lexical element level. So formatting doesn't really matter. It will be green. Yes. And it didn't touch the code because it says, oh, well, I would generate it a little bit differently, but it's essentially the same. Now, it's very nice and it works, but now I want to do something more complex. And what I would like to have is something like to have here, sorry, wrong character, display name. And the display name, I want something that testing, even with an I, that echo for the string something, we will write there something, returns. And what I want here, if I move it into the template, like this, then it will just generate, but in the place of XXX, well, eventually it returns always the same. What I would like to have there is the string itself. And I can write here string, but that's a problem because in string, I already have the apostrophes. So I could write something like, and it's still a constant string which is evaluated during the compilation time, so it can be part of an annotation. Let's do it this way. And what I see here, that still says test echo 1, test echo 2, but the code was regenerated. It's yellow and an X because we have a new code for the test. So if I run it again, I will get here already the display name text. And well, it kind of works, but I also want to have this way so that I really see that it is a quoted string. And again, I have to run it twice. And if I run it now, then I will get here the double quotes because it was changed. Now we can run it. Okay. Now we can extend it and we can say that we have a string with spaces in it, and we can also have null. And let's try what is happening then. It works nice, and it's generated again, but we have here some problem. First of all, it says that it's not a constant because it's null, and it doesn't really help even if I make it a string. It's a null. It doesn't work in cases like that. So what I have to do is first I delete it because generated code doesn't really matter, but this will run again. So we can generate it again. And what I will need is really something totally different. So what we really need is that if I write here null, then I want to appear here null like this. But if I have whoops or string and spaces and anything which is double quoted, then I want it something like whoops, like this. And to do that, I will use the replace macro, which is also part of the snippet module. And because for Jamal it's just a text, I can say replace, and then I write here first the string as a first parameter. And now I use to separate the parameters with the slash sign. And usually we can use any non-alphanumeric character, but the first non-alphanumeric character which is used after the keyword is the separator character. So we are using now slash. It's many times it's used. And what I want to replace is the double quote, and I want to replace it with a backslash, which is just a normal character for Jamal, nothing special. And I want to replace it with a backslash, the backslash quote. So I want it quoted. And if I will have null, then nothing will be replaced. And this is the end of the macro. So I will have here the string. But if there is any double quote inside it, it will be replaced with the backslash double quote. And let's see how it works now. Yes, it generated something that doesn't show any error. We have two warnings, which are, well, essentially method M is never used. Yes, we don't use it. And well, one assert equals can be simplified to assert null, but we don't want to because this is generated code. And what we have here is that we run it again, then we will run already the latest version of the generated code. And what we have here is testing that echo for the string whoops. Testing, well, English needs some testing. Let's say that testing, I put it into echo, returns itself, the same thing. And then it will be looking a little bit nicer in our test. And we run it again. And it's great. It really shows that string with spaces in it returns, but let's not that picky. String in spaces in it, null returns null. And then the code generation didn't fail because it didn't need any code generation. So generally, what we did here is that we are generating repetitive code without copy pasting. We live with this copy pasting, but we are programming the copy pasting. We can also do something very special, like I can use something that I can write here. And if you are using IntelliJ, or you are using Eclipse, or you are using even NetBeans, then using these editor folds will be generated for you, and then you can close the generated code. So when you are editing your file, the generated code will not clutter your screen and will not disturb you, because after all, the source code, the real source code is here. But when you want to debug the code, then you can jump into this because it becomes part of the source code even if it's generated. The only thing that you should be very much aware that you should not touch it, because if you touch it, you edit it, other than formatting, then it will be overwritten the next time you run the tests. And yes, I was also changing the editor code and writing an S after the return. So this one was changing the generated code. And then if I run it again, then we really have now a very nice and polished test execution where everything is in place. And I didn't need to write repetitive code.